Okay, so we're at the final question, question 7 of the Pearson's Edexcel International M2. Okay, so it's a projectiles question, but given in I and J notation, so we're given the fact that it's moving initially with 4i across and 9i up. We don't have to work out angles or anything, we can just work with our components that it's already given us. First bit, let's deal with that. Find the time taken for P to reach H. Well, it's we know that when it reaches H is where the top is at the top of its motion, that the vertically the velocity is not. If we lose v is equal to u plus at vertically, we've got the vertical final velocity is naught. The initial velocity is the 9 that we've got here, minus gt, and rearranging that we get t is equal to 9 over g, which is 45 over 9, 45 over 49 should I say, which is perfectly acceptable to give that as our answer. If you're going to work it out, then I suppose we would give two significant figures here because we've got a g in our answer. I think the general rubric is that 3 would be okay as well, but exact is also okay, so this is fine. Right, okay, so that's the first part done. Nothing too much to stretch us there. It is becoming a little bit more tricky as we go along. It's saying at the point A on its path, the position vector is the same across as it is up. So we're trying to find the point where it's exactly the same this way as it is this way. Okay, so, well, let's just look at the components first of all. I'm going to work out the time here to before working out k, because when we find out t, the time when this happens, then we're going to be able to work out k reasonably quickly from there. So if we're looking horizontally, the horizontal displacement is equal to 4t. The vertical displacement is equal to, because our initial velocity vertically was 9, if you remember, 9t minus half gt squared. So we want the time when both of these are going to be the same. Let's say that, and then we can put that back into k to work out what the k is, because once we've worked out t, we can easily work out k from using this formula, which will be the easiest one. So we want the time when the vertical displacement is the same as the horizontal displacement. So we have 4t is equal to 9t minus half gt squared. Okay, let's play around with that a bit. We can say that half gt squared minus 5t equals 0, which gives us gt squared minus 10t equals 0. If we factorise that, we get t and gt minus 10. Clearly, we're not looking for t equals 0 because that's the trivial example where the displacement is the same at the beginning horizontally. We're looking for this one. So that gives us that t is equal to 10 over g. And now, because we've worked out t, we can just go back to work out what the value of the displacement is at that time. It's basically 4 times that, so that gives us k is equal to 4 times 10 over g, which is equal to 40 over g. Okay, so that's part B done. Right, now part C, it says find in terms of k the position vector of the other point on the path where which is at the same vertical height. So if we look across here, we want the position vector of that point where it's going across. Well, we know that the vertical displacement is 40g, and the horizontal is 40g for this first part here, but we want the second time when this happens. So if we go back to that, we want the first point is this, and we want to work out the second, not the time, although we can work out the time. In fact, that's what I'm going to do, and we can work out the time when it comes to this point again. Okay, so again, I'm going to go use vertically, and going to use s equals ut plus half at squared. Okay, and we know that the vertical displacement is 40 over g equals to 9t minus g over 2 t squared. And those of you who know me know I have a aversion to reaching for a calculator in these cases. So if we multiply all that out and rearrange, you would see that we can just do a bit of work on that, and that comes to, I'll leave you to do all the rearranging, g squared t squared minus 18gt minus 80. I've times by gt and just rearranged it. Now that itself factorizes. Now you might think, well, I'm not really too keen on factorizing that. I don't like the look of it. It's really no trouble at all, because for a start we already know from our factor here that gt minus 10 has to be one of the times, because we know that's the first time when it reaches the vertical displacement of 40 over g. So that's the first time. We don't want that one because we already know it. But we can, once we know one factor, it's very easy to work out the other one, gt minus 8. So that gives us that gt is equal to 8. So t equals 8 over g. Again, it wants the position vector when this is the case. Well, so now let's go back to this formula here. We know horizontally, because that's the only thing that's going to change. Vertical one will still be the same 40 over, g or k, because they want it in terms of k as it was before. But we will see that t is equal to 8 over g. We know that if we want to write that in terms of k, that will be equal to 1/5 of k, because we've got k, as I said, it was in terms of k. And we've got 8 over g, k is 40 over g, so it's 1/5 of k is our value for t. But our displacement is going to be 4 times that. So that gives us, let's write our position vector. First of all, let's do the j bit first, because that's obviously the same as it was before, k. I'm underlining that, it's not, k is a scalar bit. We go kj. We know that's the same because by the question says it's the same point here at the height k there. Now we know that t is 1/5, and we know that horizontally it's going at a constant speed of constant at 4 meters per second. So it's going to be 4 times this answer here. So that's 4 over 5 k I. Right, it's definitely more difficult than, even though there was fewer marks, definitely more tricky than some of the earlier things that preceded it. Okay, final question, part D. Saying at time t, seconds, a particle as a point B is moving perpendicular to 4i plus 9j. You'll remember it started with 4i plus 9j, and it wants the time when that happens. Right, I'm going to draw the diagram quickly here. Starts off with 4i plus 9j, and we want the time when it's perpendicular to that. Basically, it's going to be on its downward path at some point when it's perpendicular to that time. Right, well, let's draw a slightly more helpful diagram. If I draw this one here, it's going 4 across and 9 up. Okay, right, well, at the time when it's perpendicular, remember the horizontal bit is still 4. So it needs to have the same horizontal component. Notice the vertical component has to be downwards now. Okay, so let's call that Vy or minus Vy. And we can use a similar triangles argument here, because if I can say, because these, if I work with my angles a bit, this angle here, using similar triangles or a bit of work with right angle triangles, will be the same as this angle here, and this angle here will be the same as this angle here. Okay, so I can use similar triangles, which I think is the most efficient way of doing this. You can play around with trig and all kinds of things, but I think it's quicker and more efficient to use similar triangles. I'm going to, because obviously similar triangle, we need positive lengths, and we know that the velocity is actually negative. I'm going to put my minus Vy in my triangle. Now that minus Vy there corresponds to the 4 in this triangle here. Okay, and then that equals to 4 over 9. So that gives me Vy okay, Vy is equal to minus 16 over 9. Okay, once I've got that, it shouldn't be too difficult, because I've got, I know it's going downwards at minus 16 over 9. I can use V is equal to U plus AT vertically with all the things I need to know there. I've got minus 16 over 9 is equal to 9, because that's what it started with, if you remember, minus G big T. They've called it big T in our question. So that gives me G big T is equal to 9 plus 16 over 9. So it's equal to 97 over 9, I believe. So that gives me T, the exact answer, is equal to 97 over 9G. That's exact. If I work that out to two significant figures, that's 1.1 seconds. And that's it. Not the most straightforward question, but actually I think you'll see when you unpick it and think it through it logically, it's not too bad. Okay, thanks very much. And that will be it. Switch your thing off.